make the x values go from -2 to +2. That way you get some x values on either side of x equals 0, and you make sure you get the shape, the full shape of the graph. Now, just a reminder, when we graph from a table of values, or actually I'm going to back up a little bit. Some of the problems you'll see are in function notation. So you might want to write up here at the top, just a reminder about function notation. When we have function notation, our equation looks something like this. F of x equals maybe 3x minus 1. So we're saying that if we plug in x, what we plug x into is 3x minus 1. We call that a function. This is the same as y equals 3x minus 1. F of x is the same as y equals. F of x equals is the same as y equals. F of x is just telling us we're plugging x in here to get what y is. So some of the problems you see might be in function notation. So don't let that throw you. All right, so to calculate our y values, we're going to plug x in here. So for this first one, I get y equals the absolute value of -2, which is 2. So my first point is at -2, 2. The next one, I get y equals the absolute value of -1, which is 1. The absolute value makes everything positive. So I get a point at -1, 1. Now we're going to plug in y equals 0, or sorry, x equals 0, and y equals the absolute value of 0, which is 0. So I get a point here at 0, 0. And I keep going. Y equals the absolute value of 1, which is 1. So I get a point at 1, 1. And here I get y equals the absolute value of 2, which is 2. So I get a point at 2, 2. And I'm going to connect these with a nice straight line, like so. And there would be my absolute value graph. And it says, what shape does the graph make? Well, what shape is this? A V shape. Graphs of absolute value functions always make a V shape. Anytime we graph any kind of absolute value function, if it's y equals the absolute value of something, it's going to be some kind of V shape. And because y equals the absolute value of x means, if I split this into 2 like we do with absolute value equations, y equals x or y equals -x, not -1, -x. These are lines with slope 1 or -1. So to make a graph, unless something else is done to our absolute value function, the slope is always going to be 1. Up 1, over 1. Up 1, over 1. Left 1, up 1. Or left 1, up 1. We always go over and up by 1 unless something else is done to our absolute value graph. That's how we get this V shape. All right, any questions on that first graph? Okay, let's look at another one. Whoops. I want this. So our next graph says we want, how did I do that? Our next graph we want to graph is y equals negative absolute value of x. So we're going to plug in our numbers and calculate. So for this first one, we get y equals negative absolute value of negative 2, which is negative, absolute value of negative 2 is 2. So we get negative 2. So our point is at negative 2, negative 2. Here we get y equals negative absolute value of negative 1, which is negative 1. So we get a point at negative 1, negative 1. Y equals negative absolute value of 0. Well, it's negative 0, which is still 0. Y equals negative absolute value of 1, which is negative 1. And y equals negative absolute value of 2, which is negative 2. And we connect those with a nice straight line. We get a nice V shape. And the question here asks us, what changed? We're going to call the absolute value graph that we made, the very first one, we're going to call that the parent. So if I go back here, this is my parent graph. This is the main absolute value graph. So what changed between the main absolute value graph and this one? Yeah, it flips. And I'm going to say it flips over the x-axis. We could say it flips vertically. We could say it's reflected, something like that. So this negative in front made it reflect or flip over the x. All right, questions there? Okay, let's do another one. This time we have y equals the absolute value of x plus 2. So we'll take the absolute value of what goes inside and then add 2 to it. So we're going to plug in these numbers and do our calculations. Y equals the absolute value of negative 2 plus 2, which is 2 plus 2, which is 4. So we get negative 2, 4. Do the same for negative 1. Absolute value of negative 1 plus 2 is 1 plus 2, which is 3. We get a point at negative 1, 3. Y equals the absolute value of 0 plus 2, which is 2. So I get a point at 0, 2. Here, y equals the absolute value of 1 plus 2, which is 3. So I get a point at 1, 3. And here I get y equals the absolute value of 2 plus 2, which is 4. So I get a point at 2, 4. And there's my nice V shape. I'm going to make a nice straight line through those, like so. There's my graph. V shape. Absolute value graph's always going to be a V shape. So on this one, what changed from the parent graph? It went up 2. And look what we did. added 2 outside. I wonder if those are connected. All right, questions on our graphing here? Hopefully this is pretty straightforward. Our homework is just plugging numbers into tables of values and making graphs of absolute value functions. All right, let's look at another one. Just got a couple more now. All right, there is our function notation that I talked about. F of x equals the absolute value of the quantity x minus 2. F of x is the same as y equals absolute value of x minus 2, so don't let that f of x worry you. I'm just plugging in these numbers and calculating. And here we added a few extra to make sure we get the shape, the full shape of the graph. That's why there are extra numbers in this table. So let's plug in our numbers and calculate. Y equals the absolute value of negative 2 minus 2, which is the absolute value of negative 4, which is 4. So I get a point at negative 2, 4. Here I get negative 1 minus 2, which is negative 3. Absolute value of that is 3. Absolute value of 0 minus 2, which is the absolute value of negative 2, which is 2. So I get 0, 2. Y equals the absolute value of 1 minus 2, 1 minus 2, which is absolute value of negative 1, which is 1. Y equals the absolute value of 2 minus 2, which is 0. We'll get a point at 2, 0. Plotted that there. Y equals the absolute value of 3 minus 2. 3 minus 2 is 1. Absolute value of 1 is 1. And y equals the absolute value of 4 minus 2. 4 minus 2 is 2. The absolute value of that is 2. There's my graph. Nice V shape. Connect it with a straight line. And there's my absolute value graph. What happened to that one? Yeah? One more time? If we kept graphing, they'd be the same. But we're more interested in this part, yeah? It moved over in which direction? From that one. It moved right too. Huh. And there's a 2 here inside the absolute value. Maybe those are connected. When we added 2 outside, it went up 2. When we subtracted 2 inside, the absolute value went right 2. All right, last one. This time we have the absolute value of 3 times the absolute value of x. So we're just going to plug in and calculate. So y equals 3, absolute value of negative 2, which is 3 times 2, which is 6. So we get a point of negative 2, 6. Y equals 3 times the absolute value of negative 1, which is 3 times 1, which is 3. Here we get 3 times the absolute value of 0, which is 3 times 0, which is 0. Y equals 3 times the absolute value of 1, which is 3. And y equals 3 times the absolute value of 2, which is 3 times 2, which is 6. And we'll connect that with a straight line. Like so. And how did that change from the original graph? Yeah? Right, it's tighter, it's more compressed side to side. We could also think of it as being, we kind of stretched it up more. Or it's steeper. We could think of it as being steeper because the slope of our original one was 1. Well, if we have, this is y equals 3x, the slope of that is 3. So this is steeper, narrower. So multiplying on the outside by 3 made it steeper or narrower. Definitely different than the original, but it's still a V shape. Absolute value graphs, always going to be some kind of V shape. So our homework is just sketching graphs of absolute values with different things done to them. And as you're doing this, you should think about how the graphs are changed from our original absolute value graph. When you're doing some things to the graph, how does that change it from this original graph? All right, so our homework is in the book. It is on page 257. This is section 4.4. So those 6 problems, they're all sketching absolute value graphs. Let me freeze this. And then what we're going to do next for a little bit is I want to do a little bit of practice